Hello, everybody. As we start to get settled in, we're going to review just a little bit of housekeeping today. My name is Suzanne Healy, and I am the Director of Membership and Business Development here at APA. And I'd like to welcome you to today's webinar entitled Intelligent Building Technologies for Campus and Facilities Management. A few items to keep in mind. Today's session is being recorded and will be posted to the APA website as well as shared directly to you within 48 hours. Those joining us today who requested certificates of participation or documentation regarding educational credits, this material will be issued to you within 48 hours as well. During the session, to engage with our presenters, you may use the chat feature or the Q&A feature. These both will be monitored throughout the program and queued up for usage at the end of the webinar. Allow me now to introduce our speakers for today. Paul Mills, Product Manager from DIRT Environmental Solutions, and Craig Park, Director of Digital Experience Design and Associate Principal from Clark and Enerson. Gentlemen, the floor is yours.
Well, thank you, Suzanne, and welcome, everyone. We're really happy today to get to talk to you a little bit about the future of campus planning as it relates to intelligent building technologies. Paul and I have been collaborating for a few years now, talking about where things are going, and we'll share some insights into that real soon now. Next slide, Paul.
Oops, too many screens. There we go.
There we go. There we go. So as Suzanne said, I'm Craig Park. I'm an associate principal of Clark and Enerson. We're architects and engineers based in Lincoln, Nebraska. I happen to live in Charleston, South Carolina. I'm one of those new generation of work from anywhere people. And Paul?
My name's Paul Mills. I work for DIRT Environmental Solutions. I'm the product manager and the subject matter expert for what we class as our connected infrastructure systems, which is modular power and modular networks. But just to give you a quick background on DIRT, we're a industrialized modular construction company where we manufacture interior spaces. And really, we're looking at how we can utilize that type of technology in a smart environment now. I know the accent throws it a little bit, but I'm actually in Austin, Texas, so based here in the US.
And today we're going to talk about, in 4 sections, the state of campus networks. Paul's going to go over the current environment that we see. I'm going to talk a little bit about emerging trends we're seeing in building technologies. Paul's going to follow with some words on optical networking as a framework for the future of a smart campus. And then I'll conclude with a planning framework about how do you integrate these technologies in the planning process for the next generation of campus. And we'll open it up for Q&A at the end.
So as Craig mentioned, I'm going to look at the way campus networks are today. And again, this really comes back to, from the DIRT way of thinking, is we are now looking to have interior spaces that are reconfigurable. Things change on a year-to-year basis, and COVID has shown us that. And one of the challenges that we see is, especially on the networks, is the network is tied back to the base build, which really stops any future changes or flexibility within the network infrastructure. And really, this is what we're looking at today. We've got multiple layers of single purpose infrastructure. So we've got both digital and analog cabling in certain project deployments. We've got cabling there for the network, cabling there for telephony, physical security, coax cabling for audio-visual systems. And really, we're trying to look at how we can combine all of this into a single infrastructure. And that single infrastructure really needs to be scalable and future ready. It's very difficult to really forecast what the future holds, but can we have some kind of infrastructure that will give us that potential readiness as things change? And the challenges we have, and this particular image here shows a pretty neat installation. We've got a cable tray or a ladder rack, and we've got the various cables bundled. That's great on day one, but when it comes to day 2, this is what we're seeing. We're actually seeing additional cables being installed. It might be different contractors bringing that cabling in. The raceways might be fully populated, so they're now throwing cables across ceiling grids, and we get to this particular type of situation where really the only thing that can happen here is somebody needs to go back in there and really tidy things up for the client. So we're trying to alleviate this. And one of the ways that we can do that, which I'll be talking about later, is how can we reduce the amount of copper cabling within the actual network infrastructure itself. So what is really driving this? And the key thing is speed and bandwidth. The two are different. And really, if we look at where we are today, the minimum bandwidth requirements for any new project should be 1 gigabits per second. And really on newer projects, we would advise when we're designing a network deployment, a 10 gigabit solution. So we're talking Cat6 or Cat6a there. You'll see from this graph that those technologies were actually ratified over 20 years ago. So really we're in a situation now where as technology with things like IoT, AI, 5G cellular networks now, 4K and 8K audio visual, it's really demanding higher bandwidths. So there is going to be a roadmap for 40 gig, 100 gig and beyond. And as you'll see here in 2023, in data centers, for instance, we're already talking 800 gigabits per second. The challenge is that Cat6a cannot support that. Cat6a, the maximum bandwidth is 10 gigabits per second. And historically, clients have looked at their network infrastructure, they've deployed it, and then 10 years after the deployment, they're having to rip out and replace because it no longer satisfies the bandwidth requirements. And I say to clients, would you rip out your electrical cabling in 10 years, or would you rip out your water pipes in 10 years? And obviously the answer is no. So why would you spend the money on a network infrastructure that potentially you're going to have to rip out and replace? And really what I'm asking people to do is now consider network infrastructures and technologies that are really going to stay in place for the next 30 to 50 years. So one of the key things that we're hearing now is this smart building integration, and smart is the big buzzword. We've got smart hospitals, smart campuses, smart buildings, or intelligent buildings. And really, because of the types of technologies now that are sitting onto the network, this is what is driving that bandwidth higher and higher, and the higher speeds that are required. So things like building management systems, HVAC, lighting solutions with PoE, fire and life safety, IP telephony, wireless connectivity, all of these things now are sitting on the network and really driving that need for higher bandwidths. So some of the key things that we need to be considering when we are deploying any kind of network infrastructure is ultimately it needs to be a fast and reliable internet connection. The last thing we want is downtime on our network. With COVID, obviously now things like remote learning needs to be supported. A lot of environments are moving away from a fixed cabling RJ45 connection to more of a wireless solution.
Right.
And again, we've got things like Wi-Fi 6 is available now, which is a 10 gig solution, and there's Wi-Fi 7 that will be ratified soon, which will be a 40 gig solution. So how do we support that with the infrastructure? Because ultimately, those Wi-Fi access points still need cables going to them. And how easily is it for new technologies to be adopted onto that network? As we talk about things like AI and IoT, how easy is it for those to be introduced onto the existing network infrastructure? Sustainability is a big word, and there's a lot of things we can talk about with embodied carbon and operational carbon. But again, these are some of the considerations. And obviously in a campus environment, cybersecurity is a major must. So how can we make it a more reliable and secure network at the same time? And lastly, it's great having these new technologies, but if they cost 10 times more than traditional network deployments, it's a non-starter really. So really we need to be putting forward a cost comparative solution so it's not going to impact CapEx or ongoing operating costs.
Exactly.
And then, these are the considerations for the future. And again, this is what's driving this. There's changing student needs and expectations. The spaces on campus need to be smart and safe places. And really that's supporting the student success. As I said before, the adoption of new technology and that's this digital transformation, but also the workplace, the skills required in the workplace are changing. So how can these spaces be changed or reconfigured to meet those new skill sets? And I said as part of my introduction, you know, DIRT as a solution, we have reconfigurable interior wall solutions, but if all of the network or all of the power cable is tied back to the base build, you are losing that flexibility and that agility for the future as well. It's all well and good having a flexible solution, but if the agility isn't there where you can actually make those changes easily, you've really defeated the object of having a flexible network infrastructure. So just briefly highlighting the key things that I've talked about is how can we reduce CapEx? How can we reduce operating costs? Is it an adaptable, flexible, agile solution? But more important as well is it scalable for the future? You know, on day one, you may have a need for 500 connections, but the last thing you want is to be able to have to add additional data cables on day two and have to run those cables through occupied space. So how can we limit that disruption on the network itself? And obviously, again, things like remote learning, flexibility for change, and most important is the security concerns. Okay, I'm going to hand it back over to Craig now.
Yeah.
And Craig's going to talk about the emerging
yeah.
trends.
All good points, which I'll reinforce with the next slide. You know, my favorite quote, and I've been using this for a while because he said it almost 20 years ago, was the only constant about technology is change. And so everything we do is planning for the future in our practice of where I'm responsible for our low voltage technology planning for the firm, is to look at what does it look like in 5 years or 10 years, knowing, as Paul said, that we're designing a 50-year building. So next one. I study the Gartner Group. They have an annually published what they call the Tech Hype Cycle that looks at new technologies at an innovation trigger. And on the next iteration, they look at where are those new innovations that were announced in the becoming real practical applications. Generally, this is something that gets a lot of press and raises the expectation, and as they call it, the peak of inflated expectation. But then, because it may not end up being a product that you see generally used very quickly, and this timeline is generally 5 to 10 years, that it will fall into the trough of disillusionment. And I would say right now that there's a certain amount of the AR, VR applications in that space where they are very specialized, and they hit the next trigger point, which is bespoke, where they start to become used for particular applications, and I'll talk about that in a few minutes. But when over time they become generally used, they reach what's known as the plateau of productivity. Next slide. And you see these technologies that were introduced a decade ago now becoming expected. Wearable tech, most of us have. I have a smartwatch. You probably have a smartwatch. Conversational control, I could say, Alexa, play certain music or turn off the lights in my living room, and she will do that. We're seeing AR and VR used in simulation events. And to Paul's point, we're seeing AI and machine learning start to make IoT, the Internet of Things, a very practical solutions for facilities management. So all of those are relatively new technologies. On the system side, we see advanced visualization systems in classrooms really being driven by the direct view LED market, the new, what I term digital wallpaper, adding an overlay to that allows us to use it as a touchscreen. The adaptation of HyFlex, Paul mentioned, there's a big move in higher education towards flexible learning environments that include both remote and in situ, in-room students, where we want to build systems that provide digital equity, the equivalent of being there, even if you're a remote student. And Microsoft has introduced Teams Front Row to be able to do that. Almost every classroom now is, and a lot of it was generated through COVID, was providing new collaboration tools that work remotely or in the space, and also allow you to record and archive those systems to build a library of educational content. And as we've talked about a little bit, the AR, VR, mixed reality metaverse is really starting to gain traction in engineering training and development and medical simulation. We're seeing campuses across the country building nursing and allied health and medical training. We have a great shortage for medical practitioners at all levels, and AR, VR spaces are being built into those as a way to effectively train. So as one of my friends, Mark Valente, once said, very prescient, that the slowest network our students will ever accept is the fastest they've ever experienced. We passed this threshold in 2019 where there are now more people under 40 than there are over 40. And the expectation of the digital student today is for immediate and fast bandwidth on campus, no matter where they are. So planning infrastructure looks at 5G and 6G and the coming of Wi-Fi 6 and future Wi-Fi improvements as a part of the basic planning for any network. Next one. Audiovisual, Paul mentioned the fact that those cable trays were loaded with analog cables from old AV systems, and we find that all the time. Today, we can run all of our audiovisual systems on the network on what's termed AV over IP, where everything runs on category cable, or in the future will run on fiber, on optical fiber, tied to energy management systems. So we have a holistic look at all of the electrically driven systems in the building that we can manage through a common dashboard. We can extend the Revit model. If you work in architecture and engineering, all of our designs are done in 3 dimensions using typically a tool called Revit from Autodesk. And we can now tie the building signals from those systems back to the model and see a holographic view, I would call it holographic view, of how the building is actually working from our desktop. And to the point is, working with DIRT, the ability to prefabricate materials and prefabricate systems at all levels are really speeding up the delivery of smart buildings and smart construction, to the point of 3D printing, as we see as the future of some kinds of buildings, and prefab as the other. I think that's really going to be the future of buildings.
Okay, thanks for that, Craig. So we talk about traditional copper solutions and really what is the next generation of cabling, and that is what we call optical LAN, or we're actually replacing as much of that horizontal copper cabling with fiber optic or single mode fiber. So really to look at the market itself, and this is a report from 2023 for BISRIA, and optical LAN has been traditionally very strong in the hospitality space with hotels, and that was because one of the advantages of this type of technology is we can reduce the amount of TR or IDF or MDF closets, whichever one you want to call it. And by removing that room could then be converted into a revenue driver in the way of another bedroom.
Our architects love that.
Yeah. Interestingly, you'll see from this graph that education is now the fastest growing market that's adopting this type of technology. And I think COVID has been one of the key drivers in that, because people very quickly had to adapt their environment and be able to cater for this remote learning. But also a lot of the education spaces now are really deploying much more technical types of devices like AI that need the higher bandwidth. So it's very interesting that we actually have education as the key vertical in this particular market. One other area that I'd like to touch upon is government. As you'll see here, government is the 3rd largest, and it's in brackets includes military. That's an important thing to mention, because obviously cybersecurity and having a secure network is very important. And this type of technology has been deployed on military sites in the US. It uses 128-bit encryption, so it's a very secure network, and it's much more difficult to tap into a fiber optic cable than it is a copper cable. So when people ask about the security aspect of it, this is as secure as you're going to get. So traditionally with copper, and the top left-hand image will show that, is normally you have a TR or a wiring closet, And from that wiring closet, you will either have Cat6 or Cat6a. If you're installing Cat Fiber, you need to change the way that you're designing networks, but a single cable will feed a single device on that network. And the maximum distance you can actually run that cable is 100 meters or 328 feet. And that includes patch cords at each end. It's actually 90 meters in the horizontal. So if we look at a traditional legacy network, if you've got 700 data outlets on day one, you need 700 cables to be able to facilitate all of those network devices. And 700 copper cables, especially if being run through the plenum, will need heavy duty cable trays. And as you'll see from that legacy network image, these cables, they get pretty tightly packed onto this. And yes, you'll get security people adding their cables to it. You'll get the AV guys adding their cables to it as well. So if we look at fiber in comparison, the key thing that you'll see here is we can actually run that fiber optic cable up to 20 kilometers or 12 miles. So what's the key benefit of that? Well, the key benefit is we can now bring all of the cabling back to a single location. So by removing those IDF closets or TR closets, we're also removing any power requirements. And we're also removing any cooling requirements. From an operational perspective, it's a much more efficient way of running the network using fiber compared to copper. The other key thing as well is we're actually using less switches within a fiber infrastructure. So again, even though we have some active equipment, it's far less than a traditional copper solution. So the amount of cooling that's required in the 1 or 2 TR closets is less than traditional copper. And as a comparison, the cost saving in operating costs between copper and fiber is between 70 and 80% less using fiber than it is copper. So from that one diagram there, you'll see we have a single mode fiber running all the way out to what's called an ONT, or an optical network terminal. And that ONT is the transition point from fiber back to copper, because ultimately you want to be able to plug into an RJ45 outlet. Now, with current standards, we can still run a copper cable up to 100 meters from that ONT. We wouldn't suggest that. We would suggest a maximum distance of between 10 and 20 feet, really just to allow for ease if you're adding additional cables. And when we design this type of network, we actually leave some of the ports available on the ONT. So from a scalability perspective, if you need to add an additional data outlet, rather than running cables all the way back to the IDF closet, you're actually going to run it back to the closest ONT, which is 10 to 20 feet. Now, the bottom diagram, that's actually showing the ONT being powered by a fiber hybrid cable. Now, using a single mode fiber, as I said before, we can actually run it up to 12 miles, but a hybrid cable actually includes 2 copper conductors for DC power. And obviously, because we're running power, that distance is reduced down, but it's down to 2,000 feet, which is still far better than 328 feet. So we can actually power those ONTs remotely if we need to in a dirt wall, and I'll show you an image shortly. We can actually power it locally within the dirt wall, but if you're mounting that ONT up in the plenum, you would have to run remote power for it. The ONT as well, just to mention, is a PoE device. So when we plug our copper cable into it, and we may be feeding a physical security camera, or it might be a Wi-Fi access point, we can actually run power from that ONT directly to the camera or to the Wi-Fi access point. So again, we're removing any additional power requirements for those particular devices. So this is the key difference, is where we're actually running much longer distances using a fiber optic. Now, there's another benefit as well, and that is with fiber, we don't need one fiber to connect to a single device. One fiber can actually connect up to 128 devices. And this image here is showing 2 versions of what we call optical LAN. One is an active E network and the other one is a passive optical network. So let's look at the passive optical network first. Rather than having a lot of core switches at the main distribution frame, we actually replace a lot of that with what's called an OLT, or an optical line terminal. And these are normally 4, 8, or 16 port. So we'll take a single fiber cable from one of those ports, and we'll take that fiber into a passive fiber splitter. And that can be mounted under the floor or up in the plenum. It could even be mounted on a wall if need be. And then that fiber is actually split up to 32 ways. It can actually be split up to 64 ways, but we would recommend a maximum of 32 ways. And then off each of those fiber splits, we will then install an ONT where we can run 4 or 8 copper cables. So if you look at that single fiber cable split into 32 ways, then multiplied by 4, we're actually catering for 128 devices. So the overall cabling within the infrastructure is reduced dramatically using fiber compared to copper. Now, passive optical networks are called a point to multi-point solution. As you can see here, we've got a single point of fiber coming in, and it's feeding multiple points. And the data speeds and the bandwidth for that is 1.2 gig upload speed, 2.4 gig download speed as standard. But if you want 10 gig, we can cater for that using passive optical networks. But it's a shared environment. If we look at Active E, that is where we're actually replacing the passive fiber splitter for a fiber switch, an active fiber switch. So we can dedicate 10 gigs or 1 gig or 5 gig or 2.5 gig to each user. Now, we use that type of installation where we've got audio-visual systems, primarily to cover the control. So people say, well, do we have to go with Active E, or do we have to go with PON or passive optical networks? Well, we do installations where we actually install both. We will install passive optical networks for the main building, and then where we've got AV systems, or it could be physical security cameras, we may put an Active E network in alongside. They're both using the same type of fiber. That's the key benefit. Now, the bandwidth of fiber, as I mentioned on the previous slide, Cat6a is 10 gigabits per second. Fiber, theoretically, is, you know, as much as you want to push down it. So if we move to 400 gig, 800 gig, 1.2 terabytes, the single mode fiber will be able to support that. The only thing that would need upgrading is the electronics on each end as that technology comes in. So rather than having a physical infrastructure that you may have to rip out and replace every 10 to 15 years, we're now looking at an infrastructure that's going to last for 30 to 50 years. I'll be long gone before this fiber infrastructure would have to be ripped out. And the key thing to remember as well is if you're replacing an existing copper infrastructure and you're upgrading from, say, Cat5e to Cat6a, you've still got to pull out the old Cat5e cabling. With this fiber, because we're using less cabling, you could actually run it alongside the copper cabling. There is a massive cost in removing the old network cabling, so we would suggest going with fiber in the first instance. So these are some of the components. This is an optical line terminal. As you can see, majority of these are rack mount. This unit here, this second unit, as an 8-port unit, it's what we class as 1U high, so it's 44 millimeters high, and that will cater for 1,024 data ports if it's fully populated. If you did that with copper, you'd need a full 42U rack to support that. So we can reduce the amount of racks that are actually in the comms room as well. The optical splitters, and again, as I mentioned, these can be mounted in the plenum, they can be mounted on a wall, they can be mounted under a raised access floor. They come in various configurations. You'll see some on the left-hand side, which is 1x32, so that's a single fiber coming in, and then we've got 32 fibers going out. But if you want to build redundancy into that fiber infrastructure, we can go for a 2x32 split, where we can actually bring 2 fibers into that, that passive splitter, so we can actually have redundancy on it as well. And these are some of the ONTs. Again, there's rack mount versions. Some of these can be screwed directly onto a wall. Some of these can be mounted in walls, and I'll show you an image of that. We have weatherproof or industrial types of ONTs. These are great on campuses where you may need a physical camera, or you may need Wi-Fi capability out on a sports field. Because of the extended distances, we can simply run a fiber, and that could be a composite fiber, so you don't even need power out to that location, out to the mast, and then we can run a copper cable directly up to the Wi-Fi access point or to the actual camera itself. So these are some examples of installations, and this splitter here in the center image, this is actually mounted into a ceiling chassis. We use it as like a consolidation point. So fibers will come in and then they will be split out to feed various ONTs. And obviously that's got a lockable cover on it. We've got an ONT here feeding the security camera. We've got ONTs mounted on the wall there. This could be in a hotel, it could be a classroom environment, and this is the ONT mounted on a cable tray. And as you can see, we've got a pretty big cable tray, and there's very few cables actually on that particular cable tray. So just to run through what we've already mentioned is, with this optical LAN, we've got an OLT, or we've got a top of rack switch if it's active E in our main telecom room. We've got fiber cables then feeding either an optical splitter, it could be a fiber switch, and this is really where we'd introduce our remote power. And then we're going to take single fiber cables, and I didn't mention this before, rather than using a 2-strand fiber, we can actually get away with a single strand fiber because we modulate the data at 2 different frequencies. So we will then take that into our ONT, and then our final run of copper will go to our edge devices, as you can see here. And again, these are just some examples of the ONTs. This little green connector at the bottom here, that's a Phoenix connector. So if we have this hybrid fiber cable, we can break out our DC circuit onto the Phoenix connector, and then we can bring our fiber connector into there. And then obviously these are all of our copper connections as well. So how does this look in a typical deployment? Well, this is a blown up image of an ONT or 2 ONTs in a DIRT frame. This is an aluminum frame that DIRT uses for its wall structures, and the blue material at the back, that's recycled denim, because we like to be as sustainable as we possibly can. And as you can see, this is being powered locally within the DIRT walls, because we can integrate power into the DIRT wall system. So in this particular deployment, we've got 2 ONTs, both 8-port. We've got 2 strands of fiber coming in, one feeding this ONT and another one feeding this ONT. As you can see, this bottom ONT is fully populated. So we've got cables going back up the frame that could be feeding RJ45 outlets in the plenum. They could be on other wall frames to feed RJ45 outlets. And then this other ONT here, we've only used 3 of the ports. So from a scalability perspective, we can now very easily add additional data outlets simply by pulling in more copper cables to this location, rather than pulling them all the way through occupied space to the local TR closet, which could be up to 100 meters away. So that is, a real life install. This was a project that we did in Vancouver, and because this is in the DIRT wall system, there's normally an aesthetic tile that goes over the top of this, so you wouldn't even see these within the DIRT structure itself. So really, in conclusion, and I'm just watching the time because I talk a lot, these are the key advantages of the optical LAN solution. So a single fiber cable can replace up to 128 copper cables. And, that's a big difference. That's a lot of material, a lot of cost, and a lot of weight. So we don't really need all of that, that space being taken up with those copper cables. Because of the extended distances, we can now bring all of our cabling back to a single location. So if you've got multiple buildings on a campus, or we've got buildings with multiple floors, we can actually bring all of that cabling back to a single location. And then because we're reducing the amount of horizontal cabling, and that particular deployment that we did in Vancouver, we reduced it from 700 copper cables down to 19 fiber cables. We didn't use cable tray. We actually used J-hooks throughout that particular deployment. So from a cost perspective, yes, there's less material being used on the infrastructure itself, but there's a lot less being spent on things like the support mechanisms to support those cables as well. Okay, I think I've spoken enough there. I'm
You
going to hand
did
it back
good.
over to Craig.
Yeah. So how do we plan for this? I think this is the biggest challenge we see in technology is planning for the future. So I think it's important to look at, and when Paul mentioned the word agile early on, is to make sure that one, technology planning is part of your operational planning overall, not an afterthought of now that we planned the next building, now let's figure out what technology goes in it. Make it part and parcel of the overall planning process. And I've developed this framework and been using it for a number of years, 7 steps to a really good system that ultimately, hopefully, improves learning outcomes, which is the goal of any in-campus building, provide better engagement for faculty and students, and provide adaptability for the future. And that starts with asking a question of multiple stakeholders. And I always try and say that this is not just either facilities management or IT management in the room. It's end users, both at the faculty level, the staff support level, as well as perhaps even students, if you really want to get a good perspective. I've become a real advocate for student voice these days because so many of the digital natives are defining what the future of education is going to look like. So I think it's important to include them in the conversation. So start with what's next, asking that question, and really explore through futurists like Dan Burris and Ray Kurzweil, what's on the horizon and what should we be planning for? What are the emerging technologies? Sources like Avixa and BIXI, both technology organizations, trade organizations, have great white papers on future of technology. Groups like FlexSpace and HETMA. HETMA is the Higher Education Technology Managers Alliance, and the Educational Technology Consortium are 3 good groups that look at technology all the time in academic settings. So use those resources to talk about what's coming. And then establish a clear set of goals. What's important to your campus or for this building, and create a long list of that. Decide what the impact will be. What's going to get measured? How would we know that we were successful? I'll talk a couple of frameworks of that in a minute. Talk about what's working well now. What are your strengths? What are the strengths on campus, or in a particular department or building that's being upgraded or replaced? So that you don't want to throw the baby out with the bathwater. You want to continue to use what works well, but enhance that with new technologies. The blue sky part is what are the opportunities, what could be. You get to really, I call that creative science fiction. What would be the ideal environment? And that transitions to what are our aspirations? How do we prioritize that wish list into what should be over some period of time? And ultimately defining results, or what will be, what goes into this particular project or this initiative. And then you get to do it again. And we'll talk about that too in a minute. So one of the questions or series of questions you can ask your stakeholders is, how do they know they have a challenge? What's changed? What's its impact? What's its impact on resources? What's its impact on OPEX or CapEx? What's the worst case scenario if it doesn't get solved? Is it going to cost a lot more money, or is it a benefit of scale 1 to 10? And on the flip side is, what are the results if we can improve it? What will it look like? And what's the best case scenario? So that helps define those questions of where do we want to be, and how will we know when we get there? So you can ask your technology team, what technologies can we implement that will mitigate and reduce risk and improve our stakeholder environments as it relates to technology? What can we do to eliminate inefficiencies? We're tasked on the campus, particularly on the facilities management, of doing more with less. So how can we leverage technology? Paul brought up, the applications for optical network, to me, is the biggest leverage point right now in designing the future of the building. So really would help make things more efficient across all applications. Next one. I could reduce expense. I don't know if you said the words, but I think we talk about optical networking compared to copper networking. My studies, and Paul's got some others, show that anything over 100,000 square feet has a significant reduction in cost between the comparison between cost of copper versus fiber to up to 40%. And I've heard numbers even higher than that, up to 70% as projects scale. And finally, what can we do to reduce stress? And this is, again, doing more with less. So how can we implement smart building technologies that will allow us to manage more with fewer resources? So one way to look at your current scenarios are, from what I'll call the legacy to the future, from the left to the right, and from the function, truly just basic functions we need, to innovations, what are the emerging technology we see on the future on the y-axis, and start to categorize those technologies we have in place as either being needed to be refreshed. They're a legacy technology that really needs to be brought up to speed. I'm working with a campus right now that hadn't updated their campus technology standards for almost 7 years. So it's a time to really look at a refresh. If it's a legacy and a function that works well, going back to what works well, that's maintained. But as we look to the future, what can we replace and what can we improve? And those are all questions to say, as part of this planning process that the group needs to answer. As a result, you end up with an agile technology ecosystem that really manages technology services on a regular event. I would say, it's a 3-year planning process, a 3-year sort of outcome process with annual updates to take advantage of emerging technologies that come on. It becomes aligned with the annual campus business plan. It becomes a resource for really understanding all the technology assets currently in place, an inventory, if you will, of everything that's related to technology. It allows for technology trends presentations to look at what's the future. You can engage futurists and other resources to look at the future. It helps improve the support structure on the campus. And finally, it treats the technology as an enterprise application. So it's a holistic look at all technologies. So as I conclude this piece, I would say you want to plan for what comes after, what comes next. I think that's the creative science fiction part is it's already being used somewhere. We can almost count on that. There's very few technologies that are, until our alien brothers come and land and provide us with the next new thing. There's a lot of technology out there that can be really applied. But this kind of planning process takes regular, ongoing effort. So it's like painting the Golden Gate Bridge. You start at one end, you finish, and you start over again. So it's a continual planning cycle to encourage that technology can be what it could be. And my favorite, I like to end with, we usually start with a joke, but I'll end with a joke, is that my favorite American philosopher, the Major League Baseball all-star Yogi Berra, the future ain't what it used to be. And so it's, I think that the future is what we make it to be.
Okay, I'm going to hand it back over to Suzanne now.
Yeah.
Okay, gentlemen, thank you very much for that. So we do have a series of questions that have come in. So let's start with one over here. Will AVOIP replace BAC net/IP?
So AV over IP versus BACnet IP. So they're a little bit too different. It's a little, I'll call apples and oranges here. That AV over IP is a streaming solution for traditional analog audio and video signals that allows us to manage the routing and distribution of those signals to anywhere from anywhere in a building. That management process is run through various digital signal processing computing systems using tools like Dante for audio, and I'll forget the acronym for the video side, but there's one. And where BACnet IP is the traditional management software used for managing building automation and energy management systems. So I would say they run in parallel, not as a replacement of each other. And because we're seeing now is that AV is becoming part of the network infrastructure in the same way security systems are. So we see much more where we see an enterprise network solution where data, security, and AV are running on common in our view, fiber infrastructure, but they're managed through virtual large area network software. So they're secure within each of their own environments, running on a common backbone. I hope that answers your question.
Okay, here we go for another one. What is impacting the adoption of optical LAN in the education space?
I'll answer that one. It's a reluctance to change, and and this is primarily by IT folks. Dare I say it? You know, we speak to facilities managers, and they love the idea that now we're looking to design an infrastructure that's got far less cabling, so we've freed up a lot of space in the plenum. I think the main pushback is, you know, have we got to change the way that we manage the network? And the answer is yes, if you're using what we call a software-defined LAN architecture, because it will have its own orchestration platform. But that learning curve is very fast. It's a full GUI interface. So rather than using standard command line as you would with let's say a Cisco environment, we're using a graphical user interface or a GUI interface. And that allows the user or the network manager to be able to drill down all the way down to single individual ports on the ONTs and look at data traffic, look at bottlenecks. It can look at reconfiguring the ONTs for VLANs or for quality of service. So this technology has been around for 30 plus years. And, you know, as homeowners, we're probably already using this type of technology because certain carriers are now bringing their services into our homes over
BIOS.
and then it will go into an ONT in our house, and then we'll have a connection to a Wi-Fi modem, or it could be directly to an RJ45 outlet. So the technology has been around for years under GPON technology, but then it was adapted more for the enterprise space, and then obviously it's been now taken on by educational campuses and also healthcare. So is there anything else you wanted to add to that, Craig?
Yeah, I would say that, you know, while there has been resistance, I'm starting to see acceptance and understanding. We're just starting a project with a over, I think, 525 room residence hall renovation. And it was the first time I was in a planning meeting where the IT side of the client was saying, yeah, we should really look at fiber for this, because we now know, because this is an existing building being renovated and added on, that we've seen what you showed, Paul. We show there's still Cat 3 cabling in the building. It was built in the 50s with no cabling in the building, and it's been adopted over years. And now they say, if we could really have what we want, let's start over and do it all as fiber.
I think the other thing is the perception that it's going to cost a lot more.
Right, and it's not.
You know, we by having the conversations, we can help understand that that's not the actual case.
Yeah.
Okay, which sort of ties into a little bit of the question that came in. How difficult or costly is it to replacing the existing system, and is it worth to try and do so? Obviously, you two are going to go with yes, it's worth it.
Well, I think Paul mentioned it, you know, uncabling a building is challenging, but there is certainly a sustainable analysis to say that removed copper could be repurposed and recycled. And so there's the benefit of it, of that we could take that material, assuming we can get it out at a reasonable cost, and we could resell it or sell it in the marketplace as the demand for copper is there. That's the reason people are stealing catalytic converters, is there is a demand for those materials. So I think it's a project by project analysis, but in the end, it's something that should be discussed.
Okay.
I'll put
I'm sorry, Paul.
I'll put my sustainability hat on here. This is a far more sustainable solution, both in embodied carbon and operational carbon, than copper. Now, I'm not saying that fiber is the answer to everything. People will still deploy copper solutions, but it's far easier to manufacture fiber than it is copper, because obviously you've got to take the raw material out of the ground, you've got to transport it to a factory to refine it, then manufacture it into cables, then get it to site, and you've got a lot of copper cables. So from a cost perspective, and Craig mentioned, cost savings of anything up to 40%. When we're talking to clients, they're really surprised that depending on the project design itself and obviously the size of the project, that the fiber is going to come in less expensive than copper. And that can, in our particular case, can be anything between 15 and 30% less. And I was on another webinar this morning, and it was for a resort which had got 45 buildings. It's called the Wigwam Resort in Phoenix, if anybody knows it. And they actually looked at a Cat 6 install from one low voltage contractor, and they also looked at optical LAN as the other solution. And their response was the optical LAN solution came in at a third of the cost compared to copper. And the question was asked, are we talking tens of thousands or hundreds of thousands? And they went, a lot more than that. So, we'd have to look at it on a case-to-case basis. But I think, again, this is one of the challenges that people automatically assume that fiber is going to cost more expensive than copper, and it doesn't.
Okay. Here we go. What platforms, single pane of glass, are available to allow you integration and management of the various building systems?
That's a challenge that we've seen over the last, actually, well, probably would say more than 30 years, that people have said, when are we going to get a truly smart building that integrates everything? In the last 5, we've started to see real applications coming from the AV side, interestingly enough. Crestron's IXO Cloud, AMX has a solution. I think it's, I forget their acronym, it's RMS, Room Management System, but that is able to use hooks into the BACnet platform to be able to also look at energy management within the building. There are others in development. I was just in a conference with representatives from Honeywell and I'm blank on the other ones, Trane, and a few others that are on the building management side, saying now we're looking at how we can integrate the smart communication systems from AV into our system. So I think we'll see a real quick evolution here as AI becomes a usable tool in the IoT environment. We're getting really embedded machine learning in devices, and we're seeing that as well, is that product manufacturers on the device side are putting more intelligence into the products themselves. That's going to simplify building that dashboard. Today, I'd say it's really a custom application, but there are a couple of sources that we can find.
Okay. Could wireless replace the fiber network infrastructure in the future?
So that's a really good question. And people automatically say, we go into a Wi-Fi environment. That's great, but you still need cabling, because we run cabling to each of the Wi-Fi access points. I think the important thing is that, do you have an infrastructure that's going to be able to support Wi-Fi 6, Wi-Fi 7 and beyond with a single type of cabling medium? You're only going to be able to achieve that with fiber, because the bandwidth and the speed of these new Wi-Fi standards is increasing year on year. And to be perfectly honest with you, Cat 6 and Cat 6A are just not going to be able to support that. But the other key thing as well is that cellular communications is now as important as wireless in these environments. And the great thing about fiber is we can actually use that, dare I say it, the backbone for a DAS or a small cell solution as well. So I don't think wireless will ever replace fiber, because you still need fiber as the core infrastructure. But I think more and more people are now moving over to a wireless environment.
Right. The challenge with wireless is, as we add more and more devices to it, it takes that available capacity down. And you talk about students in classrooms coming in with sometimes 3 and 4 devices. We used to design on a 2 device per person, and we've now designed on a 4 device per person. But I was on a campus last year where their internal standards are 6 devices per person. I can't imagine who that connected person is, but he's very connected. And so that the wireless access point density needs to increase, which again increases the amount of fiber connectivity we might have above the plenum to make that happen.
Okay. This really looks like it is more designed for OT networks. Is that the case, or are you seeing this with IT networks?
I'm not sure I understand the question. It is, we were talking about IT networks in our model.
Okay,
Yeah.
so my misunderstanding. What is an example of campus beyond a single building that has a network IT strategy designed to accommodate IoT, smart buildings, et cetera?
Oh, is there one out there? University of Glasgow?
They're looking for one, yeah.
Yeah, University of Glasgow is the one that I know gets cited the most in research right now. They've been doing more experiments. I can't say that it's campus wide, but they are dedicated themselves to be the campus of the future. I know that the in a recent presentations Paul and I were attended, we know the Santa Fe Public School District is running all their buildings on a fiber network now. So they've committed at a K-12 level to a multi-building campus model using passive and active optical networking.
Yeah, I think one of the, here in Texas, one of the local ISDs, which is obviously one of the school districts, just north of me, they've adopted fiber throughout. It was actually a Corning deployment. So yeah, it's now being adopted. I think sustainability is also driving this now, because more and more campuses are looking at it from a sustainability message. So they're saying, well, what can we use in the future that's going to reduce our carbon footprint?
Okay. All right. So let's close out with this last one here. Minimal downtime, obviously extremely important. How does this type of technology compare to a traditional network switch architecture?
Okay, so the great thing about fiber is we've got less points of failure within the actual network topology itself. But this technology, as I mentioned, is not a new technology. It's been around for 25, 30 years, and it's GPON technology. So the actual technology is coming from carrier class type deployments. And the last thing that those service providers want is their network going down. So what they use a term as 5 nines reliability, 99.999% reliable. So the actual downtime of the fiber infrastructure compared to copper is minutes compared to hours on an annual rate. So it's a much more secure type of network, but it's a much more efficient and reliable network as well.
Okay. All right. So that is what we have has come in, gentlemen. Very helpful. Obviously I still have some
Next
acronyms
slide,
to
Paul.
learn. Oh, do you have another
Oh,
slide?
yeah.
Just because I wanted to say, if you'd like to
Oh.
reach us, here's our contact information.
Perfect.
Yeah.
So with that, again, gentlemen, thank you very much. We hope everybody who's been able to join us and stay with us this afternoon has enjoyed this. A lot of information. As we did say, the recording will be available, as well as credit documentation within 48 hours. And we do hope to see individuals on the next session that Apple will be holding later this month. So thank you both again. Take care.
Thank you, Suzanne, and thank you, APA, and thank you all who attended.